A linear inequality is an inequality which involves a linear function. It will contain one of the symbols of inequality. This could be less than or equal to, or greater than or equal to. It can be written in one of these forms where a, b, and c are constants and x and y are variables. It's going to look like a linear equation, but the only difference is that instead of an equal sign, we have one of these inequality signs here. Let's start by identifying whether something is a linear equation or inequality. Our first step should be to look at the symbol that will tell us whether something is an inequality or not. So we have 3x plus 5y is greater than or equal to 17. Our symbol is greater than or equal to, so we know that it's an inequality. And here we have 10x minus 2y equals 30. We have an equal sign, so we know that's an equation. Here we have y minus 9x is less than or equal to 7. Our symbol is less than or equal to, so we know that's an inequality. Here we have 2/7 x plus 4y is less than 8. We have the less than sign here, and we know that's an inequality as well. Here we have 1/5 x minus y equals 10. We have the equal sign, so we know that's an equation. And lastly, we have 2x plus 4y is greater than or equal to 6. We have greater than or equal to, and we know that's an inequality. Now we're given an inequality, and we want to see whether the ordered pairs given below are a solution. So we're going to plug in the x and y values that were given. If the inequality is true, then it's part of the solution. If it's false, it's not. Now let's get started. We have y is greater than x plus 8. And we have our ordered pair as 0, 0. Let's plug in 0 for y and 0 for x. This gives us 0 is greater than 8, which is false, so this is not a solution. What about this one right here? We have 10 as y, we have 1 as x. 10 is greater than 9, that is a solution. What about negative 5, 4? Y is 4, negative 5. We have 4 is greater than 3. That's true, so we know this is true as well. What about here? We have 2x minus y is less than or equal to 16. Now let's plug in our values like last time. We have 2 times negative 4 minus 3 less than or equal to 6. So negative 8. Negative 11 is less than or equal to 16. That's correct. So we know this is an ordered pair. What about this one? 1 comma negative 2. 2 times 1 minus negative 2 less than or equal to 16. So 2 plus 2 is less than or equal to 4 is less than or equal to 16 is correct. So we know this ordered pair is true as well. What about 9 comma negative 6? Let's plug that in. 2 times 9 minus negative 6 less than or equal to 18. We have 18 plus 6 is less than or equal to 24 is less than or equal to 6. That's false. So we know 9 comma negative 6 is not an ordered pair. That's a solution. We're going to be doing something similar this time, except we're looking at a graph instead of just the inequality. So we have the graph y is less than 2x minus 4 graphed right here. As you can see, this area on the right is shaded in to show that it's part of the solution set, and the y part is not. As you can see, the line right here is dashed, and the reason why is because this is a less than, not a less than or equal to. So everything that's technically on this line is not a part of the solution. This line here, the one that's dashed, represents y equals 2x minus 4. So if it's dashed, it means there's no equal sign. If it's a full line, it means there is an equal sign. Now, let's get started. So, Let's check for 0, comma, -4. What we have to do is we just have to look here, 0, comma, -4. As you can see, this is on this dashed line here, so it's not a part of the solution. If you want to check your answer, you could plug this in. Y would be -4 times 2 times x minus 4, which gives us -4 is less than -4, which is false, hence not a part of the solution. Now we have 4, comma 0. 4, comma 0 is right here, which means it is part of the solution. What about 2, comma 2? 2, comma 2 is right here on the right side, so not part of the solution. And -2, comma 2. -2, comma 2 is here, also in the white part, also not part of the solution. So when you're given a graph, you can find the solution by just looking at the graph, or you could also check your answer by just plugging in the x and y values that you know, like what we did last time. Now, let's do one more similar problem. In this case, we have y is greater than or equal to -1/3 x plus 1. As you can see, we have a greater than or equal to sign, which is why this line here is completely full, which means that if we have a solution that's like borderline on this line, it is a part of our solution set. Now, let's get started. We have 1, comma 0. 1, comma 0 is right here, so it is not a solution to this inequality. We have 0, comma 1 right here. As you can see, it's right on this blue line, but it's a full line. So in this case, it is a part of our solution set. To check our work, we can plug this in. We get 1 is greater than or equal to -1/3 x, 0 plus 1. 1 is greater than or equal to 1 is true, hence why this is a part of our solution. We have -2, comma -1. -2, comma -1 is down here, not a part of our graph, but as you can see, it would be in this white area, so it's not a solution to this inequality. And lastly, we have 0, 0 right here, also in the white area, also not a solution. So our only ordered pair that's a solution is going to be 0, comma 1 right here. Now we finally reached our challenge problem. So our challenge problem here is to find which ordered pairs, could be multiple, are solutions to this system of linear equalities. This is going to be called a system of linear equalities because there's more than one, right? We have y is greater than or equal to 4x minus 3, and we also have y is less than 1/2 x plus 1. Pause and see if you can find the answer before I reveal it. So, we have y is greater than or equal to 4x minus 3 represented on this side, right? And then we have y is less than 1/2 plus x on this side. We know this because we can check the intercepts. For example, this intercepts at 0, comma 1 right here. But we can also see that this one is less than, so it has the dashed line. And this one is greater than or equal to, so it has the full line. So as you can see, we see this intersection of two inequalities. That's going to be a darker region, and that's going to be where the solutions to our inequalities lie, because both of the blues are overlapping each other, why it's darker. So let's check it. -1, comma 1. -1, comma 1. As you can see, it's only here in the lighter region, which means it's only a solution to y is greater than or equal to 4x minus 3, but not both. So not this one. 0, comma 0. 0, comma 0 is in both because it's in this dark region right here. That one's correct. What about 1, comma 1? 1, comma 1 is right here. In this case, it is, because it is on this full line, as you can tell, right? So 1, comma 1 is clearly in this y is less than 1/2 x plus 1 region because it covers this entire region. But it's also on the borderline of the y is greater than or equal to 4x minus 3. In this case, it's right on the equals of that. So that one is also a solution. What about 2, comma 1? 2, comma 1. No, it's only part of the y is less than 1/2 x plus 1. That's false. And what about 3, comma 2? 3, comma 2 is also only in this one section. So that's incorrect. So our answers are 0, comma 0 and 1, comma 1 are the only solutions to the system of the inequalities out of these given points. And to check your answer, you can plug in the x and y values to both of these inequalities, and they should hold true. And that's the end of today's video. Thank you so much for watching.